All right, so let's talk about those first four because those were actually on that very first day that you were solving equations. That's kind of where we started, right? So where is the sine equal to 1/2? At what angles between 0 and 2 pi does that happen at? You can use your handy-dandy unit circle. Sine is the y coordinate, right? So the first one I would say is pi over 6. The other one, 5 pi over 6. So we have pi over 6, 5 pi over 6. All right, what about the cosine being a negative square root of 2 over 2? That happens because the square root of 2 over 2, we know it happens at something over 4, right? And for it to be a negative cosine, we're in quadrants 2 and 3, right? And so in quadrant 2, the angle that happens at is 3 pi over 4, and then cosine negative square root of 2 over 2 at 5 pi over 4. So 3 pi over 4 and 5 pi over 4. Where does the tangent equal a positive 1? That's where sine and cosine are exactly the same. What angles does that happen at? At over 4s as well, right? Because that's when sine and cosine are square root of 2's over 2's. But you just have to make sure that they have the same sign, right? Either both positive or both negative. 5 pi over 4, so you went for the hard one. That's the Q3, right, where they're both negatives. And pi over 4, that's the Q1 version, where they're both positives. All right, and last but not least, and maybe the trickiest one up here, secant of theta equals negative square root of 2. And so you had to remember secant is the reciprocal of what? Cosine. So where is the cosine? Square root of 2 over 2, right? So when you reciprocate it, you just get square root of 2. And that cosine also has to be a negative. So this is actually the same question as the second one, isn't it? Yes? Anybody pick up on that? Same one as the second one. So we have 3 pi over 4 and 5 pi over 4. All right, how did those go? Nice little refresher there. All right, so we have talked inverse trig before when we were doing triangles. And remember, you could use the inverse trig on your calculator to help you find the missing angles. Do you remember that? Yes? So when we were doing this, we would say, hey, if I want to find that angle, I could take the inverse of 1/2, the sine inverse of a half. And sine inverse of a half would then tell me what angle I was looking for, right? The calculator would spit out and be like, hey, here's the angle. And so what we're going to do is we're going to evaluate each trig expression. And this is how the inverse is written. Remember, sine to the negative first says, hey, what angle gives you 1/2? Now, before we get started, if you were to do this in your calculator would only give you one number, wouldn't it? Just one number. And so when it gives you one number, we said that there's actually two places where that could happen, didn't we? But your calculator is only going to give you one. And so what happens on these inverse trig functions is that they're limited to certain quadrants. So they're not every quadrant. It's not all 4. So if you do an inverse function like this, you're only going to get one answer instead of 2. Does that make sense? Because it's going to limit it. And so here's the limitations. I have them written right here. Sine is limited between negative pi over 2 to pi over 2. So where is that on the unit circle? What quadrants is negative pi over 2 to pi over 2? Where's pi over 2 at? Let's start there. Yeah, that's up here, right? This is pi over 2. Negative pi over 2 is down here. And so your sine inverse is going to exist in quadrant 1 and technically quadrant 4, but it's going backwards, right? Into quadrant 4. So up here, this is where the signs are all positive, yes? Down here is where the signs are negative. And so sine inverse is only going to live in these two quadrants. So if somebody asks you for sine inverse of something, you are only looking here and here, okay? So when I say sine of a half, you're only going to look in quadrant 1. And you would say sine of a half is pi over 6. Or sorry, sine inverse of a half is pi over 6. Just one angle. So you're not going to say the 5 pi over 6. That is not where sine inverse lives. So they've restricted sine inverse down, saying it's only in those two. All right, the cosine is also limited. So cosine inverse also limited between 0 and 2 pi, or 0 and pi. Where's 0 at? Over here, right? Pi is over there, and so cosine inverse is only in those two quadrants, which would be Q1 and Q2. In Q1, that's where the cosine is the positives, and Q2 is where the cosines are negative, and so that's why we have Q1 and Q2. It can't be 1 and 4 again, because in 1, cosines are positive, and in 4, cosines are positive, so that wouldn't help us out. So cosine is 1 and 2. So if we say cosine inverse of negative square root of 2 over 2, you're only looking in Q1 and Q2, and since it's a negative, it's the one in Q2, and we would say that that is just 3 pi over 4. Just one answer there, 3 pi over 4. All right, and last but not least, tangent is also limited. So tangent inverse, these should all say inverses, sorry. Tangent inverse is going to be limited to negative pi over 2 to pi over 2, which is the exact same as sine, right? So negative pi over 2 is down here, pi over 2 is up here, and tangent inverse is going to live in there. And so tangent inverse is in Q1. That's where the tangents will be positive at, because sine and cosine are both positive. And then it lives down here in Q4, but going in the negatives, not going all the way around, right? Going into the negatives, Q4. And that's because tangents will be negative down here, because your sines are negative down here. So you'll have negative divided by positive, which will give you negatives. All right? So when I say tangent of 1, positive 1 is up here, yes, for tangent. So we're only going to say that that happens at pi over 4. So we're going to leave off the other one in Q3 that we had from before, and this one's just pi over 4. Possibly. Pi over 4. There we go. My board was doing so good. I thought I had it fixed, and now today it's starting to get slow again. I don't know what's going on. All right. And last but not least, secant inverse. So I don't have it down there, but where do you think secant inverse is restricted to? Secant would be the same as the cosine, right? Because secant and cosine are reciprocals. So if this is cosine inverse, this is also secant inverse. So secant inverse is restricted to 1 and 2 as well. So secant inverse of the square root of 2 is going to be the one in Q2. And the angle in Q2 where that happens is at 3 pi over 4. So we have these restrictions going on. So if I give you an equation to solve and I say, hey, find where this is equal to this between 0 and 2 pi, you're going to give me both answers, right? Both answers. If I say specifically, hey, find sine inverse, if I find sine inverse or cosine inverse or tangent inverse, you're only going to give me one answer, all right? Just one. All right, I would take a moment to add this information right here to your orange sheet. I added it to mine. It was like a late edition, but it'll be on there for future classes. So you can put it wherever you want, but I would put it on the front towards the bottom. You have some space at the bottom, yes? And so I would put it on the bottom. So you should think about this as sine inverse limited, cosine inverse, right? And tangent inverse are limited. And you can either write where they're limited, or you can draw the picture, or you can put both, whatever you want. But you're going to want to know where it does and does not exist at.
So would these be called inverse limits?
These are, I labeled it as inverse trig functions on my paper. Yes.
Do you have a Band-Aid?
I do.
So what is it? These are just examples of limits, or are these the limits?
Say that again?
Are these just examples of limits, or are those just like
The set.
the limits?
They're stuck between those. So anytime I say find an inverse, you only will pick those two quadrants.
No.
So you won't get
Like are those like an example of? Are those the only limits that we'll get for like those certain trig functions?
Yes,
Those are the only limits.
that's it. Yeah. So sine is always between negative pi over 2 and pi over 2. Sine inverse, always. And so because it's sine, that would also be cosecant, right? Yeah. And then cosine is always between 0 and pi, cosine inverse. And then tangent inverse, always between negative pi over 2 and pi over 2. And you're only going to limit if it's written as like find sine inverse of something. All right, we're going to go ahead and start evaluating some of these inverse trig functions. So the first one is sine inverse of negative square root of 3 over 2. Now there's two places on the unit circle where sine is negative square root of 3 over 2, right? But we can't use both, and we're limited to, for sine, quadrant 1 and quadrant 4, right? So sine is negative square root of 3 over 2 in quadrant 4, right? And that happens at 5 pi over 3. But if you look at what we have written up there is sine has to go between negative pi over 2 to positive pi over 2. So it is 5 pi over 3, but we need the negative number that gets us there. Does that make sense? Kind of, sort of. So if this is 0, if we're at 0, how can we go backwards to get to 5 pi over 3? 5 pi over 3 is the same as it's a coterminal angle. What gets us back here? Negative pi over 3. So if this is forward to pi over 3 to get here, go backwards to negative pi over 3, and you end up in the same spot, all right? So you're not actually using these values when you're in Q4. You're not using the actual values. You're using the negative versions of them. Does that make sense?
So negative pi over 6, negative pi over 4.
So this one would be negative pi over 6, negative pi over 4, negative pi over 3, and that, if you want that one, it's negative pi over 2. So you're using the negative versions as opposed to the Q4 versions of them, okay?
So the answer to this would be negative pi over 3.
So this one's negative pi over 3, yes. So what angle gives us a sine of square root of 3 over 2? Well, that is negative pi over 3. Whatever number you put here should live between these two numbers. So negative pi over 3 is between negative pi over 2 and positive pi over 2. All right, the next one, secant of, I'm going to make this harder. Let's put a negative in there because I can. I'm going to change that. So make that a negative square root of 2, or sorry, negative 2 square root of 3 over 2. All right. So that's an interesting way to write this. Negative 2 square root of 3 over, this is a typo, put a 3. This one's way typo. Let's just start over. Hold on. Secant inverse, negative 2 square root of 3 over 3. We're going to roll with that new question, all right? My bad. I'll have to fix that for the future. All right, so secant is the reciprocal of cosine, right? And what did we have to find the cosine of to get that 2 square root of 3 over 3? That was square root of 3 over 2. So this question here is saying the same as find cosine inverse of square root of 3 over 2 with a negative in there, right? Those are the same question, yes? All right, so cosine of negative square root of 3 over 2. Cosine lives in which quadrants? Cosine inverse is 1 and 2. So where is the cosine negative? That's in quadrant 2. And so cosine is negative square root of 3 over 2. That happens at which angle?
150.
Don't tell me 150.
5 pi over 6.
Yeah,
You said
5 pi over 6, right? At 5 pi over 6. And so the answer to this is just 5 pi over 6. We don't have to do any changing because cosine lives between 0 and pi. Cosine inverse, 0 and pi. And so that is just 5 pi over 6. That's between 0 and pi. All right, cotangent inverse, square root of 3 over 3. So remember, cotangent is cosine over sine, right? And so to get square root of 3 over 3, the cosine, the number on the top had to be 1/2, right? Looking at this chart, so 1/2. So where is the cosine of half? And to get a positive cotangent, you have to be where both sine and cosine are positives, right? So that's going to happen in Q1. All right. So in Q1, where is the cosine of half? At pi over 3. So cosine or cotangent inverse of square root of 3 over 3 is just pi over 3. All right, cosecant inverse of 2. Cosecant is the reciprocal of sine, right? So you could essentially say sine inverse of a half. So where is sine inverse of a half? Well, sine is in Q1 and Q4, right? But we have the positives, so it'll be Q1. All the positives live in Q1, right? Yes. So where's sine a half in Q1? Pi over 6. So this one is pi over 6. Needed more space here. All right, cosine inverse of 0. So where is the cosine equal to 0 at? At pi over 2. And is that okay on cosine inverse that we say pi over 2? For cosine inverse, yeah, pi over 2 is right here, so it's between 0 and pi. So you can say pi over 2 is where that happens at. All right, next one, tangent inverse of -1. For the tangent to be -1, the sine and cosine were the same, but one was positive while the other was negative, right? So where does tangent inverse live? What quadrants again? 1 and 4 down here. So where's the tangent going to be negative? Are we in Q1 or Q4? Q4. So where is the tangent -1 at in Q4? That is 7 pi over 4. But technically we can't use 7 pi over 4. We have to use the negative, right? Because tangent's positive to negative. So negative pi over 4. So the hard thing with these inverses is the restrictions, right? Knowing where to go and which angle to pick specifically. All right, questions so far. What do you think? Yes, no, maybe? Yes.
Why can't you just say 7 pi over 4?
Tangent is restricted between pi over 2 and negative pi over 2. So what they do is they restrict it. So instead of saying all of it, we're just restricting to these two quadrants because that will cover any tangent angle that we could possibly ask for. Okay. And they don't pick this one and then go all the way around and have Q4 because there's a gap between those. So to keep them adjacent to each other, they go up to pi over 2, and then they're like, well, you can go this way and get negative pi over 2 and still include that entire quadrant. Okay. So it's not like, oh, it's this one, and then if you go from here to here, there's a huge gap happening. It's so that they're next to each other. Mm-hmm. All right, other questions that you have for me so far? All right, there's another way to write an inverse function. So sine inverse, if we were to say sine to the negative first power of a half, that is the same as saying arc sine. Anybody ever see that written out before, arc sine like that?
Is it just an arc sine?
Huh?
Isn't it ARC, SIM?
Yeah, it's just ARC. So instead of having to say sine to the negative first, you can write arc sine. All right, and that is also implying that you're taking the inverse function. So there's two ways that they could write, hey, what's the inverse of this function here, right? So arc sine of negative 1/2, that is the same as saying sine inverse of a negative 1/2. Those are the same thing, okay? So it's just another notation. So we're looking for where sine is negative 1/2. Sine is in what quadrants? Q1 and Q4, Q1 and 4. By the way, it's always 1 and something, right? It's either 1 and 4 or 1 and 2. So it's 1 and 4 for sine because these are positive signs and these are negative signs. It can't be 1 and 2 because these are positive and positive, right? So that's why it's 1 and 4. So you need this sine to be a negative 1/2. That happens at this one, 11 pi over 6, but we don't say 11 pi over 6. We say it's negative angle, which is negative pi over 6. So the answer here is negative pi over 6. All right. Why don't you try those last two? You do not have to rewrite them as the inverse with the negative first. You can just go ahead and do them like normal. You don't have to rewrite them. If it helps you to rewrite them, by all means, you may do that. But you do not have to.
Nothing, just overhearing the conversation.
We're not done with notes, though, so don't give up on me yet. Don't freak out yet. Down here? Yeah, don't give up on me yet. We're not done. They're not done yet. I promise. We have more notes to go. All right, are you good on these two? Do y'all want to tell me what you got? For arc secant of 2, you could think about that as the arc sine of a half, right? Or not sine. What am I doing? Cosine, right? Arc cosine, because so cosine's reciprocal of secant. And if you reciprocate 2, you just have a half. So you can think about it like that, yes? What angle did you pick? Pi over 3, because pi over 3 is where cosine is equal to a half. Pi over 3. Cosine 1/2, yeah. Our cotangent of the square root of 3. What did you pick? What angle? Pi over 6. So that is where the cosine, right, is this, and the sine is this to get square root of 3. So cosine sine, pi over 6. All right, what do you think?
I think it's second period.
Look, it's second block. It's rainy out. This is the last lesson for this unit.
That's actually exciting.
That is really exciting, isn't it?
Are we gonna do another unit after?
Oh, of course. We still have like a whole 15 days after this.
You're not gonna give us 15 days of free time? Why not?
No, this last unit's super short.
Well, we have
What
a
is
week of free time.
Huh?
What is it?
It's using like double angles, half angles, law of sines, law of cosines.
So we're gonna have like a final over everything that we do.
No, there's no final. No, you can think of your final as the test over the last unit, but it's not cumulative. Like there's not. I mean, it's kind of cumulative because we've been using the unit circle from the very beginning, right? So it's cumulative in that sense, but it's not like a final, true final. So, yeah. All right. This is a little interesting, yes? So on the back, take a look. Don't be scared. It'll be all right. What we're doing here is we're going to find the cosine of the cosecant inverse of 2. So the first thing you're going to do is you're going to tell me where does the cosecant inverse of 2, where does that happen at, all right? Where is that happening? So cosecant inverse is sine, right? So where is the sine 2, or sine 1/2, right? Where is the sine 1/2? So where is sine 1/2 at? Pi over 6. So then what we're going to say is, hey, this value that I put in this box is equal to pi over 6. So now we're going to find the cosine of pi over 6. And then that's a question I could have asked you like 8 years ago, right? Not that far, but yeah. What's the cosine of pi over 6?
Wait, what?
Negative square root of.
Whoa, hold on. Just cosine pi over 6.
Square root of 3 over 3.
Square root of 3 over 2. All right. Just the square root of 3 over 2. So what this is you are doing an inverse, and then you are undoing the inverse essentially with this idea of like you have an inverse, and then you're going to find the cosine or a different trig function of that angle. Yes?
Why didn't you just draw like, okay, because like the problems on the homework, they're in parentheses, so I'm thinking we're going to multiply a whole bunch of stuff.
No, the parentheses is technically just a composition, so this lives inside of the cosine.
Oh, you are multiplying. It's like a 2.
Yeah, you're not multiplying here. It's like a 2-step. It's like do the inside first, then use that answer to do the outside portion.
Oh, so it's like the f of g.
It's a composition. F of g. Yes.
Parentheses.
Oh, well, here, I'll put parentheses in there for you. Yeah. So we'll throw some parentheses. So do this first piece in parentheses. So where is sine inverse square root of 3 over 2? Where is sine inverse square root of 3 over 2? That happens at pi over 3. So then what we're saying is this value inside the parentheses is pi over 3. So now we need to find the sine of pi over 3, which is equal to square root of 3 over 2. Wait a minute. We just sine inverse, and then we took the sine of it. So didn't we just do what we undid? Yes, and the answer is yes. A sine and a sine inverse are opposite operations, right? So if you take an inverse and then you take the sine of that inverse, you should get back to where you started, assuming that we're living in the same quadrant, right? Right? Because sometimes you might inverse and get a different quadrant, and then you have to just be careful. So always go through the entire step, but know that if it's sine and sine inverse of this number, most likely you're going to have that number or the negative version of that number, all right? Ooh, this one's backwards. Look at this guy.
Wow.
Backwards, yes? So the first part is, what is the sine of 0?
0.
Is 0. So then the next piece is saying, hey, what's the cotangent inverse
Of 0.
of 0? Not still 0 the angle, but where is the cotangent equal to 0 at now? So cotangent is equal to 0 when cosine is equal to 0, yes? So where is the cosine equal to 0? That happens at pi over 2. So the answer to this one is pi over 2. Now this was a sine and a cotangent, which is why the answers don't even look like where we started, right? Because they're two different trig functions. So if you have matching trig functions, like the sine and the sine inverse, you're probably going to expect to see the original thing pop out at the end, all right? But if you have different trig functions, you just need to go through step by step to make sure. All right. Up next, secant inverse of 2 square root of 3 over 3. So secant inverse is the reciprocal of cosine, right? So cosine needs to be this. This is what we're looking at here, this 2 square root of 3 over 3. So cosine needs to be square root of 3 over 2. So where is the cosine square root of 3 over 2? At pi over 6. So then we're saying, what's the cosine of pi over 6? Which is square root of 3 over 2. Yeah. Oh, there is? We'll come back to him. Just remind me when we get here. All right, up next.
You sounded so surprised.
I did?
Yeah, you said.
All right, we have cotangent inverse of square root of 3. So to get square root of 3, it's square root of 3 over 2 over a half, right? And so cotangent is cosine over sine. So it's where's the cosine equal to square root of 3 over 2? So where's it happen at? Cosine square root of 3 over 2. At pi over 6. So this is going to say we need the cosecant now of pi over 6. And that was a question from the very first unit, right? Cosecant of pi over 6. Well, pi over 6, cosecant is reciprocal of the sine. So take 1/2 and reciprocate it, you get 2. So instead of just one step like the front was, it's one step from the front, but then one step from way back, right? Way back. All right, up next. Cosine of pi. We can figure that out. That one's not too bad. What's the cosine of pi? -1. So secant inverse of -1. I'm sorry. Secant is the reciprocal of cosine, so it's 1 over the cosine needs to be -1. It's still at pi, yeah. 1 over -1 is still just pi. Yeah, so sometimes you'll get the same thing to emerge, and sometimes you'll get different things to emerge. The best thing to do is just do every step, right? Don't make any assumptions.
Well, I mean, you have the ones that are reciprocal with each other.
Yeah, most likely if you have the same trig function or ones that are reciprocals of each other, that's when you're going to see some patterns happening, right? All right, up next, we're headed backwards. Tangent of -pi over 4. -pi over 4 is down here, yes? -pi over 4, what's the tangent? -1. So then this is sine, nope, I'm on the wrong problem. This is cosine inverse of -1. What angle is the cosine inverse -1? So what angle is the cosine -1? Once again at pi, yeah. All right, and last but not least in this section, cosecant of Negative pi over 2. Negative pi over 2 is down here, right? 273 pi over 2 down here.
Yep.
What's the cosecant? Cosecant's reciprocal of sine. That's reciprocal of this, yes?
This here.
No, this is cosine. This one's sine.
Yeah.
So what's the reciprocal of negative 1? Negative 1. So then the question is sine inverse of negative 1.
3 pi over 2 just cancel it. So you get the negative pi.
Say that again, I'm sorry.
This is 3 pi over 2, but you can't do it. So you have to put negative pi over 2.
So once again, the sine is negative 1. That's what the sine inverse is saying. Is saying, hey, where's the sine negative 1? That happens at 3 pi over 2, but that's technically not in the negative pi over 2 to pi over 2, right? That sine inverse is in, so you have to say negative pi over 2. Over 2. All right. Whew. How are you doing so far?
The next one's the one I'm just scared of.
The next one, you're scared of it? Don't be scared. Are you scared because they're not on the unit circle?
Yeah.
And you're like, I have a trusty relationship with my unit circle now. I like
Can we
it.
just force them to be on the unit circle?
Technically, they're on the unit circle. Technically, you could make them on the unit circle, but they're going to be like places like here or here, right?
Jenny.
Or here. So they're just not going to be nice spots. So when I say they're not on the unit circle, they're not like your pi over 6, pi over 4, pi over 3s on the unit circle. Like, technically, they could be on there, but remember, the whole unit circle is based off of triangles, isn't it?
Uh-oh.
Oh, so we gotta go back to those trusty triangles. All of trigonometry,
Stop.
triangles, the whole thing is based off of triangles. All right, so let's draw a right triangle here.
I was gonna say I kind of forgot that we in my engineering class when we back to some trig.
Back.
It was like sine and it was like that and I was like, I
What?
don't remember. Then it was opposite adjacent. I was like, oh,
Hey! Yes, whenever we talk about sine, and we're always, you can always think of sine. Remember, if you remember on your orange sheet at the very, very beginning, the first one we put the 6 trig functions, right, was in terms of opposites and hypotenuses and adjacents and hypotenuses and all that fun stuff, yes? So if I say sine inverse is 11 over 17, 11 is referring to what side of the triangle?
Opposite.
The opposite side. And the 17 is referring to the hypotenuse, right? So I need an angle, and you can pick either angle. I always pick this angle just for reference, kind of like it's how it's set up on the unit circle. It helps me. Opposite would be over here. That side's 11. Hypotenuse over here. That side is 17.
I wonder, are we going to use Pythagorean here?
You could possibly, if you needed the adjacent, right?
Yeah.
All right. So when we say sine inverse 11 over 17, we're referring, this whole thing right here is referring to the angle that we picked. We got everything set up. So this angle here is the same as sine inverse of 11 over 17. So what we could say, right, is sine of theta is 11 over 17. And if you were doing this before, you would say theta is the sine inverse of 11 over 17. So what this first piece here is doing is it's setting up your triangle. This is the angle we have. This is 11, this side 17. We use that to set it up, okay? And so what the question is saying is now that we have that set up, we're going to find the cosecant of that angle. So what's the cosecant of this angle? Cosecant is what relationship? Wait, say that again? Hypotenuse over opposite. And how do you know it's hypotenuse over opposite? It's the reciprocal of sine, right? Sine, and so sine is opposite of hypotenuse, so reciprocate it. So what's the cosecant? Instead of opposite over hypotenuse, it's hypotenuse over opposite. So the answer to this, cosecant of the sine inverse of 11 over 17 is just 17 over 11.
That's it.
That's it. Yeah, we just go back to those trusted triangles.
I thought we were going to find like an angle would be like, you know how like 3, 5, 4, and I thought that was.
Yeah, so instead of actually figuring out the actual angle there, we're saying that angle is theta, right?
Yeah.
And then all we need to do is make sure we have that relationship so we can find the cosecant of theta.
I thought we were going to do it and find it.
Nope. All right, number the second one because I don't have them numbered. I'm gonna make myself a nice little triangle here. Put my angle that I'm gonna talk about. And so that angle has this relationship. Its cotangent is 3/4. And cotangent is what over what? Adjacent over opposite. Yes? And then now it's saying, okay, now that you have that all set up, right? That's your angle you're referring to. We want the tangent of that angle. So what is the tangent of theta? 4/3. All right, let's try another. We have secant of tangent inverse of 2 square root of 5/5. And so if we set up our triangle and we pick this angle here, I always pick the same one, just out of habit. That's going to be this relationship. Tangent is what over what? Opposite. So the opposite is 2 square root of 5 over adjacent. So the adjacent is 5. And on this triangle, now that we have it set up, we need to find the secant of theta. Secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. So this would be hypotenuse over adjacent, right? All right. So, downside. We don't have the hypotenuse, do we? We have the adjacent. It's 5. And so here's where you have to use the Pythagorean theorem.
So does that make that?
Pythagorean theorem. Y'all get super sad, right?
That make 9 right there?
I don't know. Let's find out. So Pythagorean theorem would say 5 squared plus 2 square root of 5. That whole thing squared is going to be your hypotenuse squared, right? Or your c squared. Put c in there, or you can put h for hypotenuse. 5 squared is 25. 2 square root of 5 squared. It's 2 squared, which is 4. Square root of 5 squared is 5. So it's 4 times 5, which is 20. And that's your c squared. 25 plus 20 is 45. And so to get your hypotenuse, you have to take the square root. And if it does simplify, you should, right? 45 you said is 9 times 5, right? 9 times 5, 9 is the perfect square. That's why we picked 9 times 5. So the 9 comes out as a 3. So 3 square roots of 5. So that numerator is 3 square root of 5. So yes, unfortunately, you might have to bust out some Pythagorean theorem, right?
Boo, boo, so sad.
Isn't this calculus? Why are we doing trigonometry?
What was that?
I always think, so isn't this calculus? What are we doing trigonometry?
This is pre-calculus. And in calculus, you could still use the Pythagorean theorem.
What about a 1?
Then you shouldn't take calculus. You don't use it very often, though. No, you do use it. It's in there. But you don't use it very often. All right, and last but not least,
No, do it.
you wouldn't be able to see any of it. All right, last one, not on the unit circle. Secant inverse is 17/8, so that's what we're going to use to base our theta off of. So secant is what over what? Hypotenuse over adjacent, because it's the reciprocal of cosine, right? And cosine is adjacent over hypotenuse, so It's flipped. So hypotenuse 17, adjacent is 8. And you have to say what the sine of theta is equal to. So what's the sine of theta? Sine is opposite over hypotenuse, so it's over 17, but we don't know the opposite.
Since so we spell it SOA like that.
So. Anybody know the opposite?
Let me do it in my head.
All right. You can always Pythagorean theorem, right?
Yeah. Well, 17.
I'm gonna guess 15.
Zuri's catching on to this, and I was like, anybody know what it is without doing it? It's a something special. It's not 16. What'd you say? 15.
I said that.
You did? 15?
Yeah.
It's a Pythagorean identity, and since the shortest side is even, then it's not down 1, it's down 2. I don't know if you remember that from like literally day 1, right?
Granted, it was just a very educated guess. I didn't know for sure. But
Well, you knew it had to be between 8 and 17, right?
yeah.
So at least you had that part
You
down.
know they always are like weird, like the opposite is always weirdly close to hypotenuse, and it seems really odd.
Yes. No, I'm with you. Strange. All right. Last but not least, graphs. Y'all love graphing, don't you?
I don't know.
You're like, no.
Very complicated.
All right, I'm going to show you these. You do not have to know them. You do not have to write them down. They are not on the test. They are not on anything. It is just merely for your benefit, all right? So you can see what's going on. So if we were to talk about the graph of sine inverse, do you remember the relationship between inverses and the original functions when we talk about graphing? Do you remember their relationship? The x's and the y's merely flip-flop. Now, sine inverse is restricted between what numbers? It stops at pi over 2, and it also goes to negative pi over 2. And when it does that, it hits this really nice 0 along the way, right? Zeros in between there. So what is the sine of negative pi over 2? Using your circle, sine of negative pi over 2.
I need to look at it.
Negative 1. Sine of 0 is? 0. And the sine of pi over 2 is 1. And we picked just these ones because this is where sine inverse is restricted, right? So if I want to make the table for sine inverse, based off of what I know about sine, all I have to do is flip the x and the y columns. That's it. So since we've already talked about graphing sine, graphing its inverse, not really that much more. You just got to flip it. And remember that it is restricted, right? All right, and I did change the graph around, right? I took the original and I twisted it so this would be easier because the x coordinates are nice numbers now. -1, 0, 1, not any more pi's, right? So at -1, you gotta make that a -1 and make that a positive. I couldn't change that, I'm sorry. +1, -1, right? We can just cross them off, make it -1, +1. At -1, this is at negative pi over 2. At 0, it goes through 0. And at 1, it goes through pi over 2. And it does not keep going. You know how sine keeps going? And it could repeat itself? It is done. This is it. There is no more. It is just this. So your graph literally goes, and there's these kind of curves that hit it, but that is the graph of sine inverse. The whole graph, there is nothing else going on to that graph. Kind of neat, huh? Kind of different. You probably won't ever see this graph again, but you can at least say you've seen it once. All right, let's talk about cosine inverse. Well, cosine inverse is restricted between where? 0 and pi. So let's talk about the cosine between 0 and pi. It also hits pi over 2, doesn't it? That's between 0 and pi over 2. So what's the cosine of 0? That is 1. The cosine of pi over 2? is 0, and the cosine of pi? -1. Just regular cosines. And so all you have to do to get the cosine inverse graph is you have to flip your x's and y's. So this will be 1, 0, -1, and then 0, pi over 2, and pi. And same thing on this graph, that's a -1, right? And this one you have to say is just a +1. +1. And go ahead and plot. So at 1, so this is kind of reversed, right? But at 1, this graph is at 0. At 0, the graph is at pi over 2. And at -1, the graph is way up here at pi. And it does not keep going. This is it. This is the entire graph. All you have are your curves happening. So it's going to curve down to this one and then curve down to that one. That is it. The entire graph of cosine inverse. Looks beautiful, doesn't it? Entire graph. All right. And last but not least, and like I said before, you probably won't ever use these graphs again. At least not in this class, right? We're not going to stress too much about our inverse graphs, but now you know. Tangent. Where was tangent restricted to? Or tangent inverse, sorry. Where is tangent inverse restricted to? It's -pi over 2 to +pi over 2. And so it also goes through 0. So let's get the tangent of these values. So tangent of -pi over 2. So that's the tangent of technically this one, 3 pi over 2, right? Sine over cosine? It's undefined, which means there's a asymptote, yes. Tangent of 0 is 0, and tangent of pi over 2 also undefined. Now this is tangent, so we need tan inverse, so we're going to have to do some flipping around, yes? So we'll have undefined, 0, undefined in our x's, which is kind of unique. -pi over 2, 0, pi over 2 in the y's. So the easy one to plot is 0, 0, yes? Yes. So these other ones a little bit trickier. X is undefined when y is a -pi over 2. And normally when the undefined is in the y, it's what kind of asymptote? Vertical. So if the undefined is in the x, it's a horizontal asymptote that hits y is -pi over 2. So here's where y is -pi over 2. And so it is a horizontal asymptote that runs that way. And then we also have another horizontal asymptote when y is +pi over 2. So here's +pi over 2. And once again, horizontal asymptote. So our graph lives between these two, and it's going to go this direction. In the negatives, it's going to be negative, and in the positive, it's going to be positive. And it runs along those asymptotes, and it does keep going forever to the left and forever to the right. It does keep going, but that is the entire graph. There's no additional top, bottom, all that fun stuff. That is it. So now you've seen them. Yes?
Yeah.
Yes. Huh? This tangent? Think about what the tangent graph normally looks like. It has vertical asymptotes here, and it runs up and down, right? So literally, we just took that graph and flipped it on its side. Yeah. All right. So I know that there's some. So you don't have anything on 19, 20, and you haven't done 21 or 22 yet, right? Right. Both of those pages are blank. So here's your assignment, because it's not going to be the whole thing, because that's just too much. Yeah. No.
We're doing all this in class.
Well, you'll have 15 minutes about, and then whatever you don't finish would be homework. If you want to go ahead and start, well, I'm going to decide exactly which ones I want you to do. We can do that. Go ahead. All right, so on page 19, I want you to do all 3 sections, all right? So all of page 19, okay? And then on page 20, I just want you to do number 4, just section 4. So it's just 1 through 4. So you don't need to do 5, 6, or 7. So this whole like bottom half here, don't worry about that, okay? Yes? All right. And then on page 20 and 21, you don't need to do any unless you want extra practice. All right. Page 21 is literally just what we're doing with the unit circle at the very beginning, just evaluating trig functions. And then on 22, that's where there's inverses. So if you wanted more inverse practice, you could do that, but that's not necessary, okay? So is everybody good? It's page 19 and 20 / just 1 through 4, okay? And I know like number 3 has like 20 parts, so I get that.